Good morning, everyone. We will continue the topics that we had yesterday, practicing, on these properties, excuse me, practicing on these properties. And of course, we have all these new properties we have learned, including the definition. But in addition to this, and I also want to remind you of the domain and range we talked about exponential functions and logarithm functions, okay? And then we're going to come back to continue to work on log 10, okay? Everything started from here, actually. Before, when we were doing the graph, okay, so when we were doing the graph, we were talking about when graphing one in basic one, okay, we have discussed the domain and range and the range of these functions. Okay, these functions are, we have reviewed them at the beginning when we enter logarithm. One is log base 2, right? And what else? ln x, right? Log x. Okay, so that's on the exponential, on the logarithm function. And so let me put a table here. Okay, the domain for these three. Okay, so these are the functions. And the domain for the other three, 2 to the power x, right? E to the power x. And what else? 10 to the power x. Okay, we once talk about the domain. When we're doing the graphing, we talk about the domain and the range. Okay, so still, do we remember those? What's the domain for the exponential functions?
Professor, you don't want to wait for other people?
No, they can just watch the recording.
Oh, okay.
Yeah. I figure some people are just watching the recording because they're still doing the work and stuff. So you look at, thank you for reminding me though. So when we look at these three functions, right, even though they're the base is 2, base of e, base of 10, and the exponential function, we understand they have the same domain, don't we? The logarithm, they have the same domain, right?
It's vice versa.
Right. And this is x larger than 0, and this is all real numbers, right? Correct?
Yes.
Okay, so we're rather familiar with these. And the range for logarithm of all these three functions, the range is just the other way, right? Yeah. And we will see that this is reflected on the definition as well. Okay, this is reflected on the definition as well. Okay, so here's how. Okay, so when we add a new function here, okay, log base b of x, okay, where b is greater than 0 and not equals to 1. So b is positive, not equals to 1. So the domain is still x greater than 0, log base b, okay? And the range is still from negative infinity to positive infinity. But this is referring to any base, okay, any base satisfying this condition. You follow me? So b to the power x as another function, which also has the same domain and range. You follow me? Okay, and of course, this b is also satisfying the same requirement. So now we see this will be reflected in the definition, as I said earlier. So let's watch I'm going to show you the reasoning. Okay, I'm going to show you the reasoning. Once you understand the reasoning, you don't have to remember. You don't have to memorize. That's the point I want to make, is that you don't have to memorize these, tiny little things, but very important things. Okay, so now let's see, how is that reflected on it? Okay, because b is larger than 0, not equals to 1, so b raised to the power of anything is positive, right? So if b raised to the power of anything is positive, okay, so let me write it down. Do you want me to write it down? Okay, so first I'm gonna have a narrative for it, and then I'm
Hey.
someone is really excited.
Oh, I'm on.
Okay, I just muted for now. If you want to, unmute yourself, you want to say something, you can. Okay. So now, because b is larger than 0, or this b is larger than 0, right? Not equals to 1. So b raised to power anything is going to be positive. So this is going to be positive. Okay, so this is going to be positive. Okay, so b raised to the power of anything is going to be positive, right? If b raised to the power of anything is positive, as a consequence, omega is going to be positive, right? Because omega is the same as b raised to the power triangle, yes? So as a consequence, okay, omega is positive. Omega is positive. Okay, so I hope this graph will help you to understand. I'm making that connection. So this is going to be, omega is positive. So that means this omega is positive, yes? Because this omega and that omega are the same thing. And b raised to power, b raised to power triangle is positive. That is true for any real number. Okay? And here we want to indicate that, remember that domain range of one sentence statement, right? When we did for all of these. So this is true, what? For any real number. Okay, triangle. So this triangle can be any real number. Okay, this triangle can be any real number. Okay, so I'm going to continue to make this graph, or this is just a diagram. Okay, so this guy, okay, this guy can be, this guy must be positive because this omega is the same as this omega. Do you follow me? And this triangle can be any real number. Can be any real number. Okay, so this is a positive. So omega is positive. As a consequence of that relationship, okay, and the triangle Okay, can be any real number. Do you follow me? So in this relationship, on this side, okay, on this side, it tells you about the domain and range of the exponential. On the other side, it tells you the domain and range of logarithm function. Do you follow me? And they are seamlessly consistent. So that definition have determined the domain and range for both functions. Do you understand? Do you understand? So now if you look at these relationships, you look at those 4 functions, or even, you know, however many functions you work with logarithm, exponential, the domain range is already foretold. Do you see that? Do you think you still have to memorize? Not anymore. Not anymore. They're seamlessly connected. They're seamlessly connected and seamlessly consistent. Seamlessly consistent. Okay. So in fact, if you graph all 3 in one picture, you graph all of these in one picture with any b, and they all have the same shape. So these basic functions, these 3 basic functions and more, will be represented by this general form. So this is a general form. Okay, this is the general form. Why do I say it's a general form? Because if b is 2, you get this. This is when b is 2. B is e. B is 10. And then you can create b is 3, b is 4, 5, 6, as many as you want. Okay? And this is the general form. Okay? Huh, why did it change the color? Come on. Okay? And I'm going to put this inside because this restriction is on the b's. So this is the general form for all of these. This is when b is 2, b is e, b is 10, and of course you can create more. But in general, this is the general definition, and you have special definitions for different bases. Of course, we went over that. And their domain and range is being set at the time of definition. Okay, and their graph as a result is being set at the time of definition as well. Okay, so with all these said and done, okay, so let's go back. Okay, let's go back to basic 10, to logic 10, log 10, sorry. Let's go back to log 10. Okay, so from definition, we know the domain and range is foretold, right? So let's continue. Did you guys continue on 6, 8, 9 from yesterday? Okay, so if you have, you can keep going. Okay, so this is log 10. 6, number 6, number 8, number 9. So let's work on these together, all right? So we're gonna practice using all of the, well, any one of these which is convenient, right? As a result, we'll be very familiar with them, okay? Because we have a 2 sets of other exercise ahead of us, which is very, very useful, very, very, It can be very, very difficult, but it can be very, very easy as well. That's number 6. Number 8, log base 3, excuse me. Excuse me, I hope I'm not losing my voice. Number 9, log base 4, square root of 2. Okay, number 6. Number 6, what the answer to number 6?
-1.
Very good, very good. Okay, so you haven't forgotten. We have done these, right? We've done these. So let's see where I'm gonna put it. Domain and range, I just went over it, right? So this equals to -1. How about this? Log base 3 of -5. Yeah. Bailey. Bailey.
When I was doing this one yesterday, I got stuck on it because I wasn't sure what the first step was.
Okay. What did we just talk about?
Domain and range.
We just talk about domain and range, right? And making connection with with basic 1, right?
Theta has to be bigger than negative.
This is undefined, isn't it?
Yep.
This is undefined. So what here you have is just a new rule. What we have here is just a new rule. Right? This new rule takes input, right? The input is omega. And this omega has to be what? This omega is here. B is 3, right? Base is 3. So this omega has to be what? Has to be positive. Okay, it has to be positive. Therefore, this is what? Undefined. Okay, so all of these are, part of a function. All of these questions, they're actually following a specific rule of function, Okay, don't forget that function concept. Every single one of these log 10 question, they have a related, like if you call it mother function or father function, that's what it is. And you're just reducing that expression. It's a statement. Okay, all of these, every question in number 10 is a statement. Input is such, output is what? They're asking for output. Do you follow me? Even though we did not explicitly mention function, because we want to concentrate on reducing these expressions. But in fact, they are all originated from, they all have a function, originated from a function. So all of these are statement. Some of these, for this one, you have no output. Therefore, -5 is not in the domain. Okay, so number 9. I'm glad you guys tried this yesterday, right? So number 9. So besides all of these new rule, properties, rules that we have derived, we have learned, you also need to be reminded of that the domain and range that comes with the function that connected with basic one. Okay, they're not separated. They're not separated. They're not connected. Well, they're all connected, and they all must be consistent. If you make that connection, okay, then our learning will become simpler and more straightforward. Yeah, and you'll see that they're only just statement and if statement. We will consistently see that statement and if statement. Okay, so I want you guys to try number 9. Okay, as you try number 9, I'm going to give you a couple more because some of you might have finished. Okay, so maybe number 10, right? Number 12. Number 13. Number 15. Number 16. Okay, 5 more. So we're working on 6 of them. And this time I want you guys to work on these. Okay, and just take your time. And I will chime in from time to time. Okay, so just 1 second. I'm gonna step out just for 2 minutes and I'll be right back. Where's my cup? Okay, I'm just grabbing a cup of tea. Okay, I'll be right back. All right, guys, I'm back. It was just, I have to boil the water. Okay. How's it going? Number 9. What do we get? What have we got?
1/4.
1/4. Okay, so let's check if you get it right. Any other answer? Would you like to show your work? I'm going to put question mark, okay, to be checked, okay? I'm not saying yes or no yet. Anybody want to show work? Okay, your work is welcomed. Okay, bring 1, bring 2, bring 4, bring 5, bring 6. Okay. Anybody would like to show work? Oops. Well, the easiest way to check, guess what? How do you check your work? How to check work? Right, we haven't talked about that. Even though we talk about the general principles, how to check if you get it right? How to check? Well, I think the easiest way to check is you take the base, you just go by definition. Okay, so here's my base, right? So here's the definition, right? So here's the definition. The base is 4. The base is 4. And the b is satisfied, so we don't need that part. And omega is √2, right? So omega is square root of 2, right? And now the claim is this is 1/4, right? So you just have to plug in to see, is this true? You just have to check, is this true? Is it true? Is it true? Right? That's all you need to check, right? Even though this is not the only way to check, but this is a method to check. This is a method to check. And now let's see if this is true, right? And then you're gonna work it. You're gonna work it. How do you work it? Well, I will work it this way, right? So I'm gonna make this as a 2 squared, right? And that's gonna be in the parentheses. Hold on. This is gonna be 2 squared is 4. And that's gonna be 1/4 is the power, right? And over here, this is a 2 raised to the power of half. Okay. And the left-hand side, we multiply the power, 2 times 1/4. What do I get? I'm getting an identity, don't I? Right? So this is going to be 2 under 1. So did he get the right answer? Yay! Very good job. Very good job. Excellent. So now we confirm this answer. Okay. But how did you come up with it? Did you go by, oh, you certainly can go by this way. You can go by the definition. Okay. So could you show us your work? No? Yes? There are actually a variety of ways of doing this. Okay. I don't know if everybody got, I assume you guys do it differently, right? You all do this differently. Excuse me. I hope I'm not gonna lose my voice. I'm not sick. Don't worry about me. It just I don't know what's going on. But anyway, I'm going to show you a new way to do it. I don't know if you guys did it this way. Okay, I'm going to show you the change of base formula way to do it. Okay, I'm going to show you the way that we can use change of base formula. Okay, are you ready? Now, the old one is 4, right? The new one is your choice. It's our choice. The new one, as we said, we can choose the base. If you are using change of base formula, what a new base would you like to use? Given that you can use any base.
2.
2. Okay, why not? Why 2? Tell me, why 2?
Because they could go into both of them.
That's right. I love that answer. I love that answer. Even though we can choose the any base, but sometimes you just, because we can choose any base, right? Then we just take that liberty to choose the base we think that might make it easier for us. So the root 2, this is the omega. The omega is square root of 2. So we're gonna put it in that place. And of course, it's gonna be in this place. And the old base is 4. Right? So I'm using the change of base formula. Right? So I'm going to still bring back the change of base formula. Sorry, where the change of base? Okay. Do you follow me? Then everything is easier afterwards, isn't it? The bottom is 2, the top is half. And the answer is 1/4. Because I haven't seen how you do your work, so I don't know how you have done it. Anybody would like to share your way, your work?
The only thing I did differently was I just, what's it called, put the exponent first. For the.
Oh, you work with the exponent.
Yeah.
Okay, so could you because I just want to show that there are different ways, and I highly encourage you guys to show your work. So you just work with exponents. I think that's just it is just fine. Oh, sorry. Okay. I imagine this is might be what you did, right? You have 2 raised to the power of half, right?
Yeah, and then just change the base.
That's right. That's right. Very good. That's excellent. So then you just change the base. You can see there's just so many different ways to do it. Okay, so this has become 2, what? 2 is square root of 4, right?
Yep.
2 is square root of 4. There you go. So now you have what you have now. Let's just complete it since we go by this route. This route is also, it's great. It's great. Okay, so now inside this is going to be 4 raised to the power of what? Half. So you will multiply these 2 exponents, right? That's what you did. So this is going to be 4 raised to the power of 1/4. And the answer is going to be 1/4. I think that's excellent. That's excellent. So any way you do it, just make sure you express it correctly. Okay? Because you have to express it properly. So make sure that, however many steps you show, and each equal sign is validated. Okay, very good. So the change of base formula actually is very, very useful. It's very, very useful. And because of this change of base formula and our calculator do not need so many buttons for logarithm. Okay, we understand that. So now we done number 9. So how's your guys work on number 10, 12, 13, 15, 16? How's it going? Yeah? Could I see your work? Could I see your work? You can, let's see, chat. Okay, does it matter whose work or did you want his? No, anybody's work is fine. I'm not picky about it. So sorry, I didn't look at the chat for a while. -1, I got stuck on this one because I wasn't sure that what the first step is. Okay, so I think you said something, I heard it. Cortland, no solution, good. I think that was about that log base 3 of negative, right? Doesn't matter whose work, or did you want his? I'm not particular whose work. In fact, I encourage all of you guys submit your work. Okay, because we have so many ways to do it. I want to take this opportunity to kind of show you how I grade your work alive. And if there's a mistake or first I will look for what's right. And of course, I will also look what's wrong. And we all learn from it, including myself. I learn from your mistake, and I will pay attention to that. Okay, we're gonna, that's how I pointed out these are the mistakes, because I have seen so many of them, so that you can avoid it. Okay, so I learn from you as well. And sometimes our students come up with a new method to do certain things. Maybe, the teacher haven't thought of, okay? And that is totally possible. That is totally possible. So I want to see your work. If you don't mind that your classmates see your work, do you mind? If you mind, then you can send me privately. Then I will work with you privately. Okay, maybe I can work through your work in the office hours. Okay, if you find that that is embarrassing. I only finish up to 12. That's okay. So now we're doing it. We're doing these together. No problem. Oh, no problem. But if you want to say, okay, good. We got submission. All right. I'm going to bring the submission. Bailey, you look awesome playing that guitar. Is that guitar? Hmm?
Yeah, it's a guitar.
Cool. Let's see. Cortland submitted. So let me grab the pronto message. Thank you, guys. Okay. Bailey. Okay, so let's look at Bailey's. Okay. So you guys can see Bailey's work, right? All right. So, but I'm bringing these up so that we can see better. So I can also mark on it. Okay, I can also mark on it. So so the first step, he showed equal sign, excellent. Okay, this is a great work. Okay, equal sign, and log base 2 and 1/2 is written as 2 to the power -1, perfect. and -1 is the power rule is being used, and log base 4, 2. And of course, and from here, he jumped directly to half because 2 is 4 to the power half. Okay, I think his work is perfect. Okay, very good job, very good job. So let's look at, did you guys write it down? Okay, so his work is perfect. Okay, so let's look at Cortland. Okay, and you guys could keep submitting. Let's see, did I submit? Download, okay, download and download it twice. Okay, here, let's look at Cortland's question. Cortland's, okay, Cortland's work. Wait, what's going on? Okay, here. Okay, so share screen, that's Cortland's work. He works on number 12. Okay, he works on number 12. Do you guys see the screen? Okay, so so he worked on so log base 9, very good. Okay, but I will insert equal sign for you here. Okay, you need equal sign. Don't use arrow. Don't use arrow. Okay, don't use arrow. If they're equal, use equal. Okay, so now our job here is in the entire process, you're gonna keep them equal. Okay, sorry, that's not the right symbol. So that's gonna be equal sign. Okay, so you line them up, line them up. So what he did here is log base 9, 3 to the power half, and he bring the half down, log base 9, 3, very good. And over here, of course, this 3 is 9 to the power half, therefore he got 0.5. And over here it's equal, and that's still a quarter. And his results is perfect. There's some minor, missing symbols. If you add those equal signs and line them up and make your work, you can make your work a little bit better. Removing those arrows, okay, removing those arrows, line up the equal sign, that would be perfect. Okay, but still you understand how to apply these properties. Wonderful, wonderful. Anybody else who want to share?
The question, that's right.
That's correct. The answer is right.
Shouldn't it be 1/3? And then times the, so it's 1/6.
Why is 1/6?
Because the base 9 and the exponent is 3.
3 is 9 to the power half, isn't it?
Oh yeah, there you go.
So we got 0.5. 0.5 times 0.2 so times 1/2 is 1/2 times 1/2. That's a quarter. Right?
Yeah.
Good. Okay, very good. Anybody else want to submit your work? Very good. You see, you guys are doing it. Right? Okay, so if you have any more submissions, no problem. Okay, just bring them up and I'll be happy to show to the class, unless you have special requests. You have special requests, okay? So is that okay? We passed number 10 and 12. You guys did a very good job on number 10 and number 12. So how about number 13? 13, 15, 16. as we realize, we have different ways of doing one question, and sometimes you don't need to show all these different ways, right? And as you're getting better, you sometimes you can quickly recognize which way is easier. Okay, sometimes, and you will, okay, you will be able to. Okay, for example, this one. When I look at this one, I can work with the symbols, but I probably would use change of base. I probably will use change of base. Okay, you don't have to, because you can work the other way too, right? You can work the other way too. So I'm going to use change of base. Log base 2, old base. And so here we go. We get 3/2. Okay, and of course you can do it other ways. They're all fine because one way might be simple for one person, another way might be simple for another person. Okay, which is totally fine, Okay, so I can do it this way, the power way. Okay, so what I would do is I would see it as a 4 times 2, right? And this 2 is what? 2 is a 4 to the power of what? Half. And you can even use a product rule. Remember, see, you can use a product rule here, right? You can use a product rule here. So you're gonna get log 4 of 4 plus log base 4, 4 to the power half. Boom. And there you go. You will get 1 plus half. And that's going to be 3/2. There you go. Right? So fast forward. Do you think you can handle all of them, all of the rest of them? Or shall we try a few more? So how about we try a few more before we move on to the next section? Okay. 15, 16, 15, 16. Tell me, 15, 16. What's the answer for 15? So what did you get for 15?
Uh, 15 should be undefined.
That's right. Okay, in fact, when you look at these expressions, the first thing you should check domain. Because if it is in the domain, you just work it. If it's not in the domain, the answer is easy. Undefined. Right? Undefined. Of course, in a lot of situations that the domain is not an issue. But it doesn't mean you don't check it. You check it. It's a quick check. So this requires that we are very clear about what the domain is. Do you follow me? We're very clear about these functions and these rules and this domain. Okay, so I want you guys to pick up 3 more questions. Oh, by the way, number 16, we haven't done 16 yet. So 16, how about 16? It should be easy, right? Okay, so how about you just finish it? Finish 16. How about you use change of base? So now I'm asking you to do 16 to use change of base. Okay, so log base 9 of 27. So now I have a special request. I want you to use change of base. because change your base formulas. We need some practice. Remember, there's a common mistake related to it, right? There's a common mistake related to it. And the common mistake usually happens when, we're not familiar. So I put them side by side for comparison. So do it by change of base. And you have the liberty to choose any new base of your choice. You really don't have to choose any particular base, really. Okay, you come up with the same answer. You come up with the same answer. Cool. Wonderful. Wonderful. All right. Number 16. Perfect. Perfect job, Bailey. I'm showing Bailey's work. Look at his work, okay? He did a change of base. The new basis choice is 3. And so on the old omega and old base, right? And the top is 3, the bottom is 2. Great job. Very good job. Okay, excellent. Perfect. So when I check your work, I check the equal sign. And I check if the left is equals to the one you claim to be. If the equal sign is missing, I might take points off. Because you lost the connection between the two expressions you're working with. Okay, you need to tell the reader how they're related. So equal sign, greater than, less than, whatever you do. Usually you don't use the arrow. Why not using the arrow? Arrow is a weaker relationship than equal. Arrow basically tells, arrow usually is used. Let me show you why. I don't want you to use arrow if it's equal. Okay, so arrow is used when in this situation. Okay, if A is true, then B is true. Okay. In this scenario, we write A. Hold on. In this scenario, we usually write A arrow B. You follow me? So when you say when A is true, then B is true. In this case, sometimes we use the shorthand of A arrow B. So because A is true, then B is true. From A, we get B. So far, so good? An arrow is a weaker relationship than equal. So if A is the same as B, we want you to point it out. Okay, so if A is the same as B, okay, like this is A, right? This is A, and this whole thing is B, and A and B are the same, and we want you to tell us. Do you understand? So you are telling the reader that A is the same as B. Okay? So arrow will not be strong enough a relationship. So you need to tell us. Okay, so if A is the same as B, please indicate, okay, by equal sign. So that's what we are saying. So don't use arrow. Okay. Another school of, some of our teachers, some of my colleagues, actually, I was sitting in their classroom. I was sitting in, one of the teachers' classroom, as part of my duty. And this person, this professor, he teaches that he said, okay, if you do factoring, okay, for example, x squared plus 5x plus 6, right? And then the factor form is going to be x plus 2 times x plus 3. And he was this professor telling the students, do not write the equal sign. Okay, do not write the equal sign. Well, but in the world of mathematics, conventionally, we want this equal sign. Okay, so as a professional, I pointed out to this teacher, you need to put equal sign there. And this is the answer from that professor. This professor says, and she doesn't let her student, so she refused to change. Well, then she has her academic freedom. She has her academic freedom. So I didn't want to argue. I said, okay, whatever, right? I mean, the professor did everything else okay, no problem. So I didn't want to make this a big deal. So I took this question. So I have this question. I said, is it maybe because I'm just too, I am being too picky or too rigid, right? So there's one occasion I met a professor at USC who was teaching mathematics. Okay, so he was like one of the professors when I was in school. I knew him, and I said, "Well, what do you think if And this is his comment. He said, "There should be an equal sign there. There should be an equal sign there, because what he said agrees with what I was just telling you." Okay, this equal sign tells the reader that this expression is the same as the latter one. So this equal sign actually is speaking some shorthand notation, is saying what? It's saying something, telling the reader is the same as, the former is the same as latter. So now back to the convention. So what I'm trying to tell you is that if 99% of the mathematics professors expect you to have this equal sign, do you do it or not? You do it, right? This is the reason I bring the professor from USC to this picture. And I also talked to numerous other professors about these issues in my investigation, that 99% of the math teachers, those math nerdy professors, they expect that equal sign to be there. Do you do it or not? You do it, right? And there's a good reason for it. So if someone tells you, because of this professor is still on our faculty, so I suspect some of you might be taught by this professor. We're not using equal sign in whatever scenario. And I'm asking you to change. Because you might be taught by 1% of that professors who don't use equal sign, but on the other hand, 99% of professors are using equal sign. So what do? In fact, if you use equal sign, you will never be graded as wrong. If you're missing that equal sign, you may lose a point. Okay? So did I make my point? Yeah, so use it. So if in that case, if the two expressions are the same, indeed the same, then you should let the reader know that they are the same. So by putting an equal sign. Okay, if they're not the same, if one is true, the other one, then you can use arrow. Okay, in the future, you will learn the situation that you use arrow, like in matrix operations, right? In logic, when you learn discrete math, there will be a lot of logic, right? One is A is true, then B is true. In that case, they're not equal, but one will lead to the next. A will lead to B. So we are pretty particular about these notations. So without further ado, and I think we should take a break. But before we take a break, just hold on a second. Do we have another submission? Do we have another submission of work? I want to go over that before we take the break. Okay, hold on. So let's see. So that's the only one. Wait. Yeah. Okay. So we've gone over all of the work. Okay. I'm going to put back to the share screen. And the right answer, of course, is log base 3, and you guys done a perfect job. Okay, log base 3, 27, and log base 3, I'm just copying Bailey's work. Okay, so he got 3/2. That's wonderful. That's wonderful. Very good job. And I would ask you to look at during the break. During the break, you should be taking a break, but just in case you have any questions for the rest of log 10, you can bring them up. And now we're taking a break. We're going to take a 10 minutes break. Come back at 9:15. Okay, come back at 9:15 p.m. I will see you later. All right, guys, please come back. Welcome back. We are going to look at the next two sets of exercise, which is log 13a and log 14a. Okay. These two sets of exercises primarily uses the product rule, quotient rule from one side to the other. Okay. So let's look at some examples. So I'm going to do some exercise from 13a, and then I'm going to pick some exercise from 14a so you can see a comparison. Okay, they really just be using the product rule, quotient rule, and in addition, okay, so primarily product rule, quotient rule. Okay, so I bring the mistake with it. Okay, I'll bring the mistake with it. Okay. On these, and of course, from time to time, you also get to use the power rule, okay? The power rule, which is right here. So these group of exercise primarily uses these three properties, usually. Then you'll say, why? Why you take a formula from left to right and right to left? Well, they each have their purposes. They each have their real applications. So for us, we just need to practice this skill, just practice this skill. So in time when you're in calculus class or in your other classes, you might get to use it. You might get to use them, okay, according to the need. Now, so let's take one in, the first one in number 13, okay, 13a, okay. For you to watch the comparison, okay, I'm going to set up a table here. Okay, so one is from 13a. Okay, and the other one is from 14a. Okay, just for the fun of it. Okay, so number one, I choose one from 13a. Here we have log base 3. Oops. Log base 3, 8x. And I will choose one from 14a. Okay, which is, I'm also going to choose number one, which is going to be log base 4 of 6 plus, plus 2 times log base 4 of 7. So what we see here is that the question in log 13a, this is a single log. This is a single log. And this is not a single log. There's 2 logs, right? 1, 2, right? 2 log in addition or subtraction. So the task in 13a is to expand. Okay, so task is to expand. And the task in 14a is to combine into one single log. You guys see the difference? So that it's opposite operation. So for number one, the answer here would just be what? You just use the product rule. Log base 3 of 8 plus log base 3 x. You're done. Do you guys get it? On the other one, however, you're gonna make it into 1 log. Along the way to make it 1 log, obviously we can think of product rule, right? So number 13a is about using product rule or quotient rule from left to right. On log 14a is about using product rule or quotient rule or power rule from right to left. Do you follow me? And that's exactly what you do. Now, before we combine these two into a single log, we have to use power rule. We have to use power rule. Okay, so the base 6 and base 4, sorry. And you need to bring this 2 inside. So that's log base 4, 7 to the power 2. Okay, and the next step would be, now you can combine that into a single logarithm. Single logarithm, which is going to be 6 multiply 49. Got it? So that's the difference between these two kinds of exercises. Okay, so this is called a single log. Okay, 1 single log. Okay, and this one is expanded. All right, did you get it? So let's practice some more. Let's practice some more. You know what? I'm gonna keep it, keep these. Oh, that's fine. I think it's fine. Okay. So let's choose, we're gonna choose, I'm gonna choose some for you, okay? For example, I'm gonna choose, one for you. How about I choose number 8 on 13a? So, okay, on 13a, okay, on 13a, expand, I choose number 8 for you. On 14a, I'm going to choose number 3 for you. Okay, so I'm going to make some more choices for you. Do you want me to do more examples, or you think you can handle it? The next one I choose is going to be number 7, number 8. Maybe we can even do number 6, right? That looks like fun. Number 5. 5, 6, 7, 8. Okay, let me put them in order. I like things to be in order. 8. Let's see, I'm going to choose number 10. Number 11, number 12. Try those. Okay, and once again, I would welcome all your contribution. Okay, sharing of your work. Okay. Be aware of the way we write it. Okay, line them up. Line them up. Oh, I should put it this way. If you wish to submit your work, please do. Greatly welcomed. Greatly welcomed. We practice our basic skills, very basic skills. Okay, be aware of those mistakes. You see how tempting, right? How tempting sometimes to use those to go with that mistake. It's very tempting. But don't do it. Don't do it. Nice. Nice. Wonderful. All right. I think I don't have to download this. I can just show this picture here. You can see the moment you send something to Pronto, I get it immediately. Okay, my cell phone will prompt you, as you have it probably experienced. Whenever I send a message, you see it right away. Okay, so Pronto is a very good tool. Let's look at Bailey's work. Do you guys see this? Does everybody see this? Wait, new share. Okay, that's the share. Okay. You know, Bailey, there's a half natural log A plus half natural log B. That's perfect. Okay. It's a great work. Equal sign is properly placed and being expanded. And if you need more steps, you could insert one step. And obviously, I think he really got the hang of the formula, so he can just go straight. He can go straight. That's okay. That's perfect. Anybody else would like to submit your work? Good job, Bailey. Let's see, chat. There's something on the chat. If I did have, that's okay too. That's okay too. Okay. Yeah. Portland says, okay, I'm gonna bring this up. Okay, I'm gonna bring this up. Okay. So this is referring to the question of number 8, right? Number 8. Number 8, we want to expand. Okay, so the given expression is ln root of AB, square root of AB. The work you could show is half ln A plus ln B. You must have this parentheses. Okay, because we're asking to expand, so Bailey's final result is preferred. You know what I mean? Bailey's final answer is preferred. So if you get to this point, if you get to this place, I mean, it shows that you've used the product rule and power rule properly. For me, either one is okay. For me, either one is okay, but in some situation, you may want to go to the final step, go to this step. Okay, so this depends on the situation, because here, okay, both results demonstrated you know how to use power rule. You need to understand what we're trying to assess is here. What do we try to assess here? We try to assess you know how to use the power rule and you know how to use the product rule. The last step, okay, the last step show you how to know, you know how to use distributive rule. We already expect everybody knows how to use distributive rule. So in my grade, for this class, when I'm grading, either one is okay, because either one has demonstrated you know how to use the power rule, you know how to use product rule. That's enough for me. So either one is okay. Is that clear? However, in some situation, this one might be preferred. Okay, in some situation, this might be preferred, depending on your situation in the future. In some other situation, this one might be preferred. Do you follow me? So I cannot foretell that. Depend on what situation you're going to be. But for this class, either one is okay. Okay, either one is okay, because all I wanted to know is that you know how to use power rule and you know how to use product rule. Got it? Okay. All right. Moving forward. Okay, I want you guys to do one in 13A and then do another one in 14A. Just do left and right and left, and do that kind of thing. Okay, if possible. More contribution. Do you want me to do another example? Or you think you're good? If you want me to do another example,
Maybe another combining example.
okay, I'd be happy to. Okay, let's do another combining example. Okay. Number 3. Well, how about you point to one? You pick one or two.
Number 2 is good.
Number 2?
Yeah.
Okay, why not? Number 2. Number 2, we have half log base 2 of 5 minus 2 times log base 2 of 7. So we cannot use a quotient rule right away. You see, we cannot use a quotient rule right away, because to use a quotient rule, we should not have any other number in front of the logarithm but 1. See, this has to be 1, right? And this has to be 1, right? So we cannot use a quotient rule right away yet. So we're going to use a power rule. We're going to use power rule from right to left. So this half is going to go inside the logarithm. Okay, so log base 2, 5 raised to the power of half. So we use a power rule. And this one, for the 2 times log base 2, 7, we have to do the power rule again. So it's going to be 7 to the power of 2. You guys see that? You can write any way you want, really. You can write square root of 5. You can write 49. No problem. They're no problem. Okay, they're all fine. So if you write it this way, so you say, oh, I want to write it as the square root of 5. And here I'm going to write 49. No problem. Okay. And the next step, finally, we can do the quotient rule, which is the numerator. This, okay. Okay, let me put a quotient rule right here. And so this is the capital X, which is a root 5. It's going to be on the top, and the other one, 49, in the bottom. And you're done. Done. Finished. So what we are assessing here, okay? So you need to understand, you need to know what your teacher are looking for. We're looking for that you use the power rule properly, okay? Use the power rule properly. Whether you write a square root of 5 or you write 49 instead of 7 squared, it really doesn't matter. You just have to make sure. So these 2 steps, you only have to show one of them. If you show both, no problem. If you show one of them, that's fine. Got it? And we also are looking into if you use the quotient rule. Properly. So these are the two main things we are assessing. Okay, we are assessing. Does the student know how to use it? Right? Make sense? Does it make sense? Okay. So do you think you can go on? You want me to do one more?
I have a question about number 3.
Number 3, yes.
So for that second log, when you put the 3 as the exponent, would you foil the x plus 1, or would you just leave it as x plus 1 to the power of 3?
I would leave it. I would not foil it.
Okay.
Good question. Good question. Okay. Because if you foil, it's going to be a much more complicated expansion. In fact, you will find out once you get into your calculus class, you realize we prefer factored form. We prefer factored form. In a lot of situations, we prefer factored form. Okay, let me say it again. We prefer factored form in a lot of situations. I'm not saying in all the situations. We prefer factored form in a lot of situations. Okay, and fundamentally is because the mathematical principles, right? If you look at the 6 mathematical principles, I always want to take you guys back to the basics, right? So you can see the simplicity. If you look at the 6 mathematical principles, how many of those principles do you think involve factoring? I want you to look at look at those 6 mathematical principles, and you look at those principles, you think about how am I going to make use of those principles? How many of those principles that you think will require to have factored form? Is my question clear? Principle number 5 needs factored form to apply. Principle number 6, to apply principle number 6, we need a factor form. Yes? Principle number 4, to a certain extent, we need a factor form. We want factor form. Principle number 1, we need a factor form. Do you follow me? Do you follow me? And of course, there will be in particularly, variety of situations. If 4 of the 6 principles prefer factored form, so do we understand why factored form is preferred? Yeah? Does that make sense? Yeah. So once you get into your calculus class, in a lot of situations, you will see that you like to have the factor form. You like to have the factor form because with factor form, you can do so much more. Okay, with factor form, and at the other side is 0, right? Those if statement, right? If the product is 0, if the product is positive, the product is negative, and so on and so forth. Remember those things we've done? Very, very common occurrences in mathematics. Okay. All right, so keep going. Okay, so I just chimed in. Okay, so hopefully I will inspire you to think about these connections. Okay, so once again, I talk about there are only 2 kinds of sentences in mathematics. One is a statement, and one is an if statement, right? Right now, we are just handling statements. We're not handling if statement. We're going to be handling if statement next week. Okay, all of these are statement. we're manipulating that given statement with some specific forms. With some specific forms. All right, I think we don't have a whole lot of time left, so I'm going to just get on get on the action, okay? And you can just continue to practice after the class, okay? And so as we just mentioned, number 3, so we're gonna write it as this form, okay? So here, this is a 14a, right? You would do log x squared minus a log x plus 1 to the power 3, right? And then quotient rule. Okay, so x squared and x plus 1 to the power 3. You're done. You see, you're done. Okay. We prefer factor form. On number 13a, there's one number 12. Okay, I'm gonna skip some of those exercises. I'm gonna work on number 12. Number 12 looked like one of those questions I have seen in Cal. For whatever reason, okay, you will find out. Okay, so I'm gonna make the font just a little bit bigger so you can see the negative sign. What's the 175%? There you go. You see the minus sign, right? So here, you're gonna have the half, right? And you're going to have that ln x plus 1 minus ln of x minus 1. Right? So you have ln x plus 1 minus half ln x minus 1. At this point, you're finished. You're done. But isn't it so tempting for some of our students to do the following? Right? Yes? Do you guys see how tempting to do that? Do you see how tempting to do that? Very tempting. So when you're doing this, you have committed a terrible mistake. Do you guys see that? It's very tempting to do. Okay, it's provided you do algebraically correctly. So tempting to do. So tempting. I can feel it. Okay, I can feel that temptation. So tempting to do. But terrible mistakes. Do you follow me? So please don't do it. All right? Okay, very tempting to do. Okay, remember that mistake I pointed out, right? What mistake did I point out? What kind of mistake we pointed out? The mistake that we said ln x plus y equals to ln x plus ln y, right? And the other mistake was what? Ln x minus y equals to ln x minus ln y. Remember those mistakes we pointed out much earlier? Terrible mistake. They're terrible mistake. Okay? So don't do it. You're done. You're done here. Okay, we're done. I'm perfect. Okay, don't do the following. Okay? All right. Did you write it down? I'm asking you to write down the mistakes. Okay, you can see so tempting to do. So tempting to do. All right. Okay. Without further ado, let's do a couple if we can on 14A. Okay, so now I'm going to take the lead because we're getting near the end of the class. If you have questions, please don't hesitate. And you just need to practice after class and just redo everything we did in class. Okay, one of the questions I like to do is, I selected that question for you, which is number 6. Okay, do you think you want me to do that? Number 6 can be done in many different ways. And I want to point out one of the ways that might be a little easier. Okay, so 3 times ln x minus 4 times ln y minus 2 times ln z minus ln w. Okay, so I'm just going to go straight to, you can try other methods, you should end up the same answer, okay? So I'm going to have ln x raised to the power 3 minus ln y to the power 4 minus ln z squared minus ln w. So what I like to do, or like to show you, is that obviously you can see that you're going to use product rule, you're going to use a quotient rule multiple times, right? Instead, I'm going to factor out the negative sign. Okay, so all of these will turn into plus. And my final answer would be ln x to the power 3. So inside the parentheses, I'm going to use the product rule, y to the power 4, z squared, w. If you wish, you can put in parentheses, but the parentheses is optional. Okay, and then my final step would be ln quotient x raised to the power 3, and the denominator would be this guy. I thought this way might be a bit easier. Okay, and number 7. This is one of those questions I have tested my former students many times. And of course, I see all kinds of mistakes. Okay, and this one, you're going to apply product rule, right? So you're going to have a plus b multiply a minus b, right? If you like, you can put a bracket, but it's really not necessary. Okay, minus ln c squared. The next step, quotient rule. So ln, okay. Some people like to write it in factor form or in expanded form, but it's okay. Doesn't matter. Okay, if you write a squared minus b squared, that's fine too. C squared. That's it. You're done. But I see all kind of mistakes. Okay, I've seen these mistakes. Okay, in terms of handwriting, you have to make sure you write it down properly. You have to write down the properly. Some people give the answer like this. Okay, so this is the mistake I've seen. Ln a plus b times a minus b divided by c squared. Do you see the mistake? All of these need to be together before ln apply. And this one separated. Okay, that's a mistake number one. Okay, mistake number one. Another mistake I saw in the past. Okay, it is like this. And it turned into a 2C. Okay, I don't know how the student got it, but it's a mistake. Did I see other mistake? I might have, but I don't remember. Okay, not sure anymore. Okay, not sure anymore. So these are the correct steps. You can see each step of the way there could be. And the optional step here, some people like to say, oh, I'm going to expand it. I'm going to expand this into a squared minus b squared. That's okay. That's totally fine. That's totally fine. No problem. Okay. So another answer is also no problem. Okay. If you want to sub the whole thing over here. So all of these are fine. Okay. 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 So everything here is okay. Okay. And this is the optional. And that is the optional. Okay, so this last one is also optional. So I'm giving the optionals. Okay, and commonly seen mistakes are these, especially when you write on paper, you have to be very, very careful. But last but not least, I think we still have a little time. Number eight. Oh, number eight, I've seen all kinds of mistakes. See all kinds of mistakes. This would be typical of something you might see in calculus 2. Okay, you do your integration, and in the last step, you end up with ln something like this. This is very straightforward of using quotient rule. Okay, x minus 1, x plus 1. You're done. This is done. Done, done, done. However, the mistake I've seen in the past, okay, the mistake I've seen in the past are the following. It's just awful. It's awful. Okay, so what kind of mistake is this? It's not only these kind of mistake repeated. Okay, it also mingled with the mishandling of absolute value. Okay, is mishandling with absolute value. Okay, so this kind of mistakes show up again. You see, so these kind of mistakes show up in different shapes and forms. You guys see that? And there's also, in addition to these mistakes, there's additional mistake, which is the mishandling of absolute value. You cannot separate, right? So the additional mistake, is what? I speculate, I'm speculating really, because I don't know exactly what's on people's mind, okay? The additional mistake involves something like this, which is a terrible mistake, right? We pointed out in the absolute value part in the early pages, I believe either page 3, page 4. I believe it's page 3 on the notes. And of course, the other one is also very rampant. All of these are, I would say, okay, these are terrible mistakes. All of these are terrible. These are awful. Okay, so I pointed out these mistakes, okay, and I hope you will avoid these mistakes. And some of these mistakes is just a different version of the mistakes we pointed out earlier on, right? For example, what kind of mistake is this? Right? What kind of mistake is these? Well, this is basically, it's another form. It's this original form is really the mistake of absolute value of a minus b equals to the absolute value of a minus absolute value of b. These mistakes are very rampant. And rampant means what? It's like pandemics. It's like pandemics. Okay, all of these are mistakes. You see, these mistakes is a different form of that mistake. This is the general form of mistake we have pointed out. We have counter examples for them. We knew there were mistakes. So mistake. Okay, so let me emphasize their terribleness. Okay, terrible. Okay, you guys? These are the mistakes we math teachers sees, like, they die pretty hard. They don't die very easily. Dying hard mistakes. Okay, so let me have a new word for it. Die hard mistakes. They are truly die hard mistakes. I don't want you guys to make those mistakes. Okay, so that's all for today. Have a great weekend. Trust me, I will not be giving you additional quizzes. Okay, you already have 3 quizzes this weekend. I trust you're gonna do well. But any question you have, please don't hesitate to reach out to me. And I will see you guys on Monday, if not sooner. And I'll be in my office hours, of course, after this. Okay. Have a great day and a wonderful weekend. And stay healthy and stay safe. Very good job participating. Okay, I appreciate all the contributions you have made to the class, which make the class much more interesting. Thank you, thank you, thank you.